In 1943, while the world's brightest physicists split atoms for the Manhattan Project, the American psychologist B.F. Skinner led his own secret government project to win World War II, not with bigger weapons, but with pigeons trained to guide bombs with deadly precision. The idea struck him as he gazed out the window of his train on the way to an academic conference. "I saw a flock of birds lifting and wheeling in formation as they flew alongside the train. Suddenly, I saw them as devices with excellent vision and maneuverability. Could they not guide a missile?" Skinner started his missile research with crows, but the brainy black birds proved intractable. So he went to a local shop that sold pigeons to Chinese restaurants, and Project Pigeon was born. Though ordinary pigeons, Columba livia, were no one's idea of clever animals, they proved remarkably cooperative subjects in the lab. In his lab, Skinner trained pigeons to peck at aerial photos for food rewards. The goal was to place them in a bomb's nose to guide it by pecking a live target image. Though the military never used these pigeon-guided bombs, Skinner saw something bigger. Pigeons were reliable instruments for studying, learning, acting like living machines. Skinner's work with pigeons didn't just end with the war, it planted a seed that would grow into modern AI, connecting a 1940s lab to today's tech revolution. People looking for precursors to artificial intelligence often point to science fiction by authors like Isaac Asimov, or thought experiments like the Turing test. But an equally important is Skinner's research with pigeons in the middle of the 20th century. Skinner believed that association, learning through trial and error, to link an action with a punishment or reward, was the building block of every behavior, not just in pigeons but in all living organisms, including human beings. His behaviorist theories fell out of favor with psychologists and animal researchers in the 1960s, but were taken up by computer scientists, who eventually provided the foundation for many of the artificial intelligence tools, from leading firms like Google and OpenAI. These companies' programs are increasingly incorporating a kind of machine learning, whose core concept reinforcement learning is taken directly from Skinner's school of psychology, and whose main architects, the computer scientists Richard Sutton and Andrew Barto, won the 2024 Turing Award, an honor widely considered to be the Nobel Prize of Computer Science. Reinforcement learning has helped enable computers to drive cars, solve complex math problems, and defeat grandmasters in games like chess and Go. But it has not done so by emulating the complex workings of the human mind. Rather, it has supercharged the simple associative processes of the pigeon brain. Sutton calls it the bitter lesson of 70 years of AI research. Copying human thinking failed, but pigeon-like learning, linking actions to rewards, unlocked AI's potential. Today, reinforcement learning powers chatbots at companies like OpenAI. Early models like GPT-3 used human-labeled data, but reinforcement fine-tunes them with feedback. Newer models claim to reason, but Sutton calls it hype, just clever associations like a pigeon pecking for food. He believes AI could become superhuman by learning from its own experiences, potentially creating a world driven by pigeon-like intelligence. In 2017, Google's AlphaGo Zero learned Go from scratch, using rewards to invent strategies in days that took humans centuries. If computers can achieve so much with pigeon-like learning, what does that say about the birds themselves? A 1964 study showed that pigeons could learn to discriminate between photographs with people and photographs without people. Researchers simply presented the birds with a series of images and rewarded them with a food pellet for pecking an image showing a person. They pecked randomly at first, but quickly learned to identify the right images, including photos where people were partially obscured. The results suggested that you didn't need rules to sort objects. It was possible to learn concepts and use categories through associative learning alone. AI is making scientists rethink animal smarts. Ed Wasserman at the University of Iowa trained pigeons to ace a categorization task that stumped college students, who searched for rules while pigeons learned through practice. In his most famous experiments, Wasserman trained pigeons to detect cancerous tissue and symptoms of heart disease in medical scans as accurately as experienced doctors. Proving associative learning is powerful, not basic. Pigeons don't just mirror AI, they reflect us too, showing how simple learning shapes complex lives. Skinner, who died in 1990, would have loved this. He saw learning as the key to behavior, even pushing odd ideas like a baby box called the air crib, which aimed to simplify baby care by keeping the infant behind glass in a climate-controlled chamber and eliminating the need for clothing and bedding. While some fear his behaviorism reduces animals to robots, researchers like Robert Rescorla argued associations help animals understand their world's structure. Pigeons even sense their own feelings in drug tests, hinting at introspection. Unlike AI, pigeons feel joy and pain. As AI mimics sentience, it pushes us to ask, how do we spot true consciousness? Humans rely on associations too, for tasting wine or sorting objects, blending pigeon-like instincts with unique gifts like language. From a wartime dream to the heart of AI, the pigeon's simple learning has reshaped our understanding of intelligence. In labs, computers, and our own minds, these birds remind us, even the smallest ideas can soar to great heights.